Hi, and welcome back to the Low Level Devel channel's Gameboy Emulator development series. In the previous video, we covered the jump-related instructions in the stack. In this video, we're going to cover the arithmetic-related instructions such as add, sub, inc, dec, etc. So let's get started. First, I'm going to quickly run through adding these to our instructions map. So looking at the inc. Okay, so I want to add these increment instructions. Alright, starting with 0, 3, BC. We'll do the same for B and inc C. So now I'm just going to do the same thing. I'm kind of going to run through this pretty quickly, not expecting you to follow on and type as I do. Just to get this part out of the way. Okay, we're in the L. And then the last one is the SP and HL. Now let's look at the dec instructions. This would be for decreasing a value of a register or memory location. And I'm probably going to go back through in another video and just revalidate these, because I'm kind of just adding these as I go along. I'm not infallible. I'm likely to make a mistake here or there. But for now, we're just putting these all in place, and then we'll go back and double check them all later. Let's see, this should be MR, I believe. Yep. Okay, so that should be all the dec related ones. And you can see some of these will be modifying the flag, some of them won't. Alright, and yeah, let's go to proc. I'm just going to create a new function, a new handler, I guess you'd call it. So this one will be for the inc. And to start with, we're just going to read the value of the register for the current instruction and increment it by 1. So that's the simple part, but there's a little more to it. So once we've incremented, oh, hold on, let me go back and find, we have some specific behavior for 16-bit functions. So what I'm going to do is just create a is 16-bit function. And this is going to take a register type, and it's just going to return RT is greater than or equal to RTAF, because those are the 16-bit functions. So if you remember in LD we used that same kind of check. So I'm just going to update that here so that it uses it as well. Now I'll copy and paste it down in our new function. And in this case, we want to check reg 1. So if it's a 16-bit instruction, we need to add 1 extra cycle. And another thing we need to check is if it's an HL is the register that we're working on, and this is a memory destination, so the mode is, let's see, we could use memdest, so I'm going to say mode is AMMR, so memory location of a register. Then we're going to get the value from that register, so bus reading the location of that register, and we're going to AND it with 0xFF to just get that bottom byte. and then we're going to bus write the value +1 essentially. So the reason we're doing that 0xFF, because if the value is FF, it's going to increase it by 1 and it'll be over 1 byte in size. So otherwise, if it's not that, we're just going to do the simple set reg to the value that we got. And val equals CPU read reg1. So we're going to reread that value afterwards. And then finally we have another condition. So if the bottom 3 or bottom 2 bits here are both set, then we can just skip because those do not set the CPU flags. We can see that here. Let's see. See these ones that end with 0x3 and the ones that end with 0xb. There's going to have the bottom 2 bits set. So those ones do not modify the CPU flags. So now we can just update the CPU flags. So val equals 0 for the Z flag, 0 for the null flag. We do our half carry, and we don't touch the carry flag, just as it says right here. Z0H dash. Okay, so that should be all for the increment function. We can actually copy this and paste it for the decrement because it's going to be very similar. So of course, instead of +1, it'll be -1. Let's see, this should remain the same. This 2. I'll make that -1. We actually should not need that. We can just get rid of that. I think so. Or we'll just keep it there. Let's see, and set reg, that's all stays the same. Yeah, we'll just get rid of that. And yeah, that should be all. So the decrement function is pretty simple. After you've completed the increment function, it's all the same. These values will, instead of 3, will be 0xb. And this is set to 1 on the decrement, as per the matrix there. Then I think that's it. 0x0f instead of 0. And now we're good on that. So let's go ahead and add these to our processor map. In dec equals proc dec, and in inc equals proc inc. And now let's do a quick sanity check. Sure we can still make it. Everything looks good. Let's do a quick run. And this one. Okay, that wasn't a good one. Let's see, mem timing. Okay. Yeah, we have some inks that were called there. And the values look correct. 392, 393. Then it goes to 395, but that's because this LD instruction is the so that's HL. Let's look at this. So 392, 393, and 395 are the values after those increments. So if you look at this load instruction, load with the opcode 2A, The reason it jumped from 0393 to 0395 is because the 2A opcode is actually a load HL plus. So once you load into HL, then it increments HL. So that's the point of that. Let's see, if you want to take a look at that, we can look at this instruction 2A 395. If we look at the matrix 2A, it's the HL plus. So that makes sense. Now let's move on to adding some more of these instructions. So 39 is add HLSP. So let's go on and just start adding these other instructions. And we're going to start with the add instruction. So let's do a Control F and look for add. So these are all the instructions we're going to handle. There's some 16-bit ones, these are some regular 8-bit ones. So one that takes a value, and then another 16-bit one with a value. Okay, so let's move on to the code and we'll add a new function for add. So we'll call this one proc add. And we're going to start with U32 for the value because we could be reading 16-bit ones and they might increase over or overflow, I guess you'd call it. So we'll read the value for reg 1 and then add the value of fetched data. Okay, now we have a couple special cases. First of all, let's find out if this is 16-bit. So we'll invoke that is 16-bit function on register type 1, reg 1. So now if it's 16-bit, and the first thing we need to do is increment the CPU cycles. And for now we'll leave that section by itself. So now we're going to check the special case if reg 1 is SP. In that case we need to, let's see, read the value reg 1 plus and casting to character fetch data because it might be negative. So in that case we need to make sure that it subtracts because there is no sub version of that instruction. So now checking the flags, so for the Z flag we of course make sure that bottom byte is 0. For the H flag, let's see, we will grab the bottom nibble, make sure it's greater than or equal to 0x10 when we add them together. Okay, and something similar for the carry flag, but we will use FF and FF 0x100. And okay, so that will actually handle the 8-bit instructions. So for, again, 16-bit instructions, these are going to be a little bit different. In the 16-bit instructions, Z is not modified. H is going to be similar, but instead of using 0x0f, we use 0x0fff. Same with fetched data. So 0x1000. And then for C, we're actually going to grab an int 32 or u32. Read the value of reg1. Add with the value of fetched data. Casting everything to u32 so there is an overflow that makes it smaller. So now C will be n is greater than or equal to 0x10,000. Okay. Now another special case, if reg1 is the stack pointer, it has its own kind of rules for these. Maybe I'll just copy from one of these. Let's see. I think that one should be similar. I'm just gonna paste these here. Rearrange this so it's a little easier to see. Okay. Yeah, so essentially these, for the stack pointer, these are going to act like the 8-bit version. But since stack pointer is a 16-bit register itself, we kind of just need to redo that code there. It's probably a more efficient way to do this, but I'm just trying to make this code as readable as possible. So now we do CPU set reg val and 0xFFFF, and CPU set flags to the Z0, H, and C values. That should be it for the add function. It's actually a pretty complex function overall for as simple as what it does. So let's take this code and let's make sure we covered all these. ADC is going to be the next one. So that's the add with carry, which is actually a lot simpler than the regular add. First of all, let's put add in here. So let's call this one ADC, proc ADC. So we're going to use U16 as the value here because these are all going to be 8-bit instructions. So just setting up our values here. Just to make it a little easier to read, I'm going to use these temporary variables. So now ctx.regs a equals a plus u plus c. And then ANDed with the 0xFF. And that's because these ADCs always work on the accumulator, not other registers. That's why this one's so much simpler as well. Okay, I think that does it for half carry, and then carry is just as simple. Alright, so that's really all there is to ADC. Now we'll do sub. We'll do probably sub and SBC in this one. So sub also doesn't have 16-bit instructions, so it's going to be simpler than the add one as well. So I have sub and SBC. Sorry if you hear background noise. I have some neighbors doing some construction work. So let's do sub. Read current instruction, read reg 1, and then of course minus the fetch data. So if val equals 0, then that will be the Z flag. With H flag, I'm doing a little bit of casting here. The reg 1 ended with that one nibble. Same with the fetch data, less than 0. And then the same thing for C, except we do the we do the full byte, so we don't need to AND it. And so now we should be able to just set the values. So set the value of the register to the value and set the flags. Z1HC. And that's all for proc sub. So now we can do SBC, which is actually similar to sub. So, and SBC is subtract with carry. So this is going to be, instead of just minus CTX fetched data, we're actually going to, let's see, think how to do this best. We just say val equals fetch data plus CPU flag C. We'll say Z is CPU read reg, current instruction reg 1 minus val equals 0. And let's see. Alright, I'm going to make these 2 lines to make them a little easier to read. Okay, so we'll say minus int flag C and minus int flag C. Okay, so now when we set the register, we'll just do what we did here. Set that to minus val. And let's see. That should be all. So now let's go ahead and add those to our map. So we have ADC. Then we have sub and SBC. Sub and SBC. So that should cover all of our arithmetic functions. Let's do a quick check here. Yeah, we want to go through and add these to our instructions map as well. First of all, let's change a couple things. So in proc SBC, this should actually be U8, not U16. And then there's some issues here. So in C, that should actually be greater than or equal to 0x100. And let's see, is 16-bit H should be greater than or equal to that. Okay, so now those are fixed. Let me go and add these to our instructions map. I'm just going to kind of zip through this real quick. So 0, 9, 1, 9, 2, 9, and 3, 9. So then I'm going to add each of these. HL, that should be a MR, and A. And let's see, should we have the add SPR one? Or add A and D8 and add SPR. Okay, so now let's do our ADC. Again, I'm not expecting you to follow on. I'm just kind of zipping through these quickly so we're not taking up so much time. Those should be all fine. And then this one ADC with a D8 at CE. And now sub and SBC. I can just copy this whole 0x8, change this to 9, change these to sub, change these to SBC. And that's pretty much all. Those follow the same pattern, which is nice. So let's do a make. Rerun our CPU instructions. Okay, we see that some decks were called there. Let's do the mem timing. We have some decks there as well. And let's see. Yeah, there's an add instruction called there. So yeah, I think that's probably a good point for now. So before we end, I want to update some of the logging that we do so we have a little bit more information to look at when we're checking our instructions. So in our CPU.c, I'm going to add a section for the flags so we can see which flags are set easily. So I'll just do a char flags, and 16 is large enough for this. So we'll do %C, 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 %C. And we'll say, let's see, actually that should be flags, not SZ. Okay, so regs F and 1 shifted over by 7, so that's going to be the Z flag. So if that's set, we'll do Z, otherwise dash. And then we'll just do one for each of these flags. So we have 6, 5, and 4. Those are going to be the N, H, and C flags. So then we want to put those here. %S. And where did we put those? So right after regs.a, we'll just put flags. So now when we run it, we should be able to see the different flags. And also, let's put the current tick that we're on too, so we can see how many ticks there are once we got to this instruction. So it'll essentially be timer, clock, emulator cycles, I guess you'd say. We'll say EMU context ticks. Okay. And I'm making that, yeah, I'm making that a max of 8 characters. Looks like there should be LX. Alright, yeah, let's just go ahead and change that. %Z 08 LX. Make. Okay. There you go. So now we have the current emulator tick that we're on as well. So that'll increment pretty much 4 for every CPU cycle. Well, no, not 4 actually. This is going to be CPU cycles. Yeah, and that'll change as we update the EMU cycles function, but just to give you an idea what this looks like, and we'll continue on that part a little later. So I think this is probably a good stopping point. You can see me running some different ROM files through here. This one actually made it pretty far, 3032 as the tick that it's up at, before it hit something that stopped it. So anyway, I hope you learned a lot from this video, and in the next video I think we're going to cover some of the bit operations, and then we'll be pretty far along and most of the way through all the different instructions to finish up the CPU. We'll probably finish up the CPU in the next couple of videos. So again, I hope you enjoyed this video. If you did, like, comment, subscribe, join our Discord server, which you'll see in the comments, and thanks for watching.